Good morning, all of you. How are you? Anyone, please, you can respond. How are you all? Are you seeing your unit test and internal marks, right? Of TOC. I'm audible, right? I'm in the meet. Students, I'm audible, right?
Yes, ma'am.
Yes. Thank you, Vishnu. After long gap, anyone please, can you able to remember what is TOC and what are the things we have studied so far? The first and second unit. Yes, students, anyone please? What is TOC? Theory of computation. What is the finite automata and what are the types in automata? Yes. In second unit, what we have discussed? Can anyone please respond? Then only I can start third unit. Based on the first unit only, we are going to discuss about third unit. Please recall everything. What is in TOC and what is in the automata? What are the types? Okay. What are the types in finite automata?
Deterministic and non-deterministic.
Yes, very good. Yes, Leela only coming to respond. Okay, fine. Thank you, ma. What's the difference between deterministic and non-deterministic?
In deterministic, for one input, it will go to only one state. In non-deterministic, it can go to many states.
Yes, yes, very good. Like that, we have another one automata. In third unit, we are going to study another one automata in third unit, push down automata. Okay. Push down automata is nothing but it is a combination of finite state machine plus stack. You know the stack, right? What is in stack? What is in stack data structure and what are the process we can do in stack? I have studied in data. Yes, yes, Vishnu.
Push, pop.
Okay. Push means we can insert the element, right? In the case of pop, we can delete the element. Okay, so this is the stack data structure. If you combine the finite state machine and the stack data structure, obviously we are getting the push down automata. Okay. If you're going to define a finite state machine means formally we are going to design how many tuples in that particular machine. With the help of how many tuples we can define the finite state machine. Students, DFA or NFA or how we can say finite state machine, how many tuples we can represent, we are using to represent the particular machine. The definition of DFA and NFA we can mention, right, but particular tuples, 5 tuples. Okay, with the help of that 5 tuples we can describe the finite state machine. Here in the case of push down automata, another 2 more tuples are added. Okay, so we have 7 tuples to describe the push down automata. Okay, we are going to see the push down automata and context free grammar in third unit. Okay, we'll see. My screen is visible, right? Students?
Yes, ma'am.
Okay, ma'am. Thank you. So now we are going to start our third unit of TOC. This is nothing but context-free grammar and languages. Okay. Have you heard about grammars in TOC? Type 0, type 1, type 2? Yes, students, have you heard about type 0, type 1, type 2 grammars in TOC?
No, ma'am.
No, okay, fine. In the case of language, we have some grammars, right? If you're taking the English, that is one of the language. For making a sentence and use that particular language, we having some grammars. With the help of this grammar only, we are doing that, we are using the particular language, right? Like that, here also we are having some grammars. With the grammars means we can say rules, right? Rules to be followed to continue with a particular language. So we can say here we have some grammars, 4 types of grammars that denotes the rules of the TOC, rules of the production or rules of the grammar. Okay, with the help of this grammars, we can do with what languages and process and so on. Okay, so context free grammar is one of the grammar in that 4 types. Okay, the push down automata can only access or only do the process on CFG. CFG is nothing but context free grammar. This is the syllabus of third unit, CFG, past free, ambiguity in grammar. What is the ambiguity? Can you anyone please tell me the meaning of ambiguity? Normal meaning. Okay, no issues. Ambiguity in grammars and languages, and moving to push down automata and how we can convert the CFG to PDA and PDA to CFG. Okay. And normally the push down automata is called as non-deterministic push down automata. Okay. In finite automata, we have 2 types, deterministic and non-deterministic. Normally, generally, the push down automata is nothing but it's a non-deterministic one, not a deterministic. This is the non-deterministic one. Non-deterministic means, what is the meaning? For a single state, we can travel from, we are traveling from one state to another state means, we just with a single input, we can go with one from another and one from next, I mean another state also. With the help of single input, we can travel to more than one state. Okay, this is the non-deterministic one, right? So this is our syllabus. First, we are going to see about grammars. Okay, here we have 4 types of grammars: type 0, 1, 2, and 3. Type 0 grammar is known as unrestricted grammar. There is no rules in type 0. Okay, there is no rules. The grammar may be in any form. Okay, and type 1 is known as context sensitive grammar, and the type 2 is context free grammar. This is the grammar we are going to see in the third unit. Okay, context free grammar. Okay, this is the grammar we are going to see in the third unit. Before that, we just go through what are the grammars available in TOC and what is the rules begin that. Okay, and type 3 is nothing but regular grammar. Okay, these are the 4 types in grammars. This is the hierarchy. Type 0 is nothing but what? Unrestricted, no restriction. Okay, which can accept by, which can implement by Turing machine. We will see this Turing machine in the 4th unit. Okay, this is why what is made that push down automata and Turing machine, why we are studying this in TOC? Can you able to imagine what are the things happening in here? TOC is nothing but a designing model. Okay, that particular model which can able to accept some string or accept some patterns. Okay, if you are generally, we can define the pattern. Based on that, we can accept all the strings inside that. Just like simple computer, like that we can say, right? We are going to design one model. For that, we are using different techniques: automata, push down automata, and Turing machine. Okay, like that we can say this is a simple computer. Computer is nothing but what is that? Doing some computation based on some inside, based on some process, based on some condition inside. We are designed inside the computer. The programmer design something, based on that the computer will work. Like that we are create a simple, we can say this is a simple computer. Okay, so this type 0 grammar can able to recognize by Turing machine, and type 1 it can accept by linear bound automata. This is another one type of automata. And the type 2, that is nothing but context big grammar. This is accepted by the push down auto. We can implement this grammar. We can design a model, or we can design design a system with the help of push down automata. Okay, and type 3 is the acceptable finite automata. Already we have studied what's the regular grammar, regular expression, like that you may study in the second unit, right? That is accepted by the finite automata. Now we are going to see which one: context free grammar and push down automata. And before that, you have to know what is the condition, what is the rules of type 0, type 1, type 2, and type 3. Okay, you can able to then only you can able to differentiate. First one is the type 0 grammar. Okay, here there is no restriction. Okay, there is no restriction. In type 0 grammar, the productions, we can say this is the productions. Okay, production or grammar or rules. Okay, this is the production which have no restriction. Okay, this is called type 0 grammar. Okay, there is no restriction. Before that, in this production we have some elements, right? This is called production. S tends to ACAB. Okay, some have you heard about the terminals and non-terminals? A student, have you heard about terminals and non-terminals, ma? Anyone, please? Have you heard about terminals and non-terminals? Yes or no? I'm audible, right, students? I'm audible, right? Students, anyone please can respond? I'm audible. My screen is also visible.
Yes, ma'am.
Yes, Leela only in the meet, right? What about others? What's your plan? Monday onwards, we are going to meet in offline, right? If I'm asked anything, you can respond now. What's the problem in that? Almost 147 people in the meet. In that only one can respond, right? What about others? I want just at least 10 responses. Okay, otherwise I will mark you and call. Okay, please cooperate. At least 5 students try to respond for my questions. Okay, Okay, type 0 grammar is nothing but is a production with no restriction. Okay, this is the production. Okay, S tends to some. This is a grammar or production. We can say grammar or production. In that, which of the letters are mentioned in capital letters, then we can say that is the non-terminals. Okay, non-terminals. Which of the things, which of the letters mentioned in the name of capital letters, then we can say that is the non-terminals. And which are the things mentioned in small letters, we can say that is the terminals. Okay, this is the terminals. The terminals only come in the leaf node. Okay, we can derive from the non-terminal. We start with the start symbol and we can substitute some grammars for that and try to get the string which we want. Okay, so this is the production and grammar. This is a type 0 grammar. Type 0 grammar means there is no production, there is no restriction on that particular production. Okay, it is in the form of alpha tends to beta. There is no restriction on terminals and non-terminals. Okay, we can have terminals in left side and right side and non-terminals in left side and right side. Okay, there is no restriction on the production. This is called type 0 grammar. Okay, is it clear? This is a type 0 grammar. In that we have to know what is by terminals and what is by non-terminals. Terminals is nothing but the letters which are denoted in small case. We can say that is the terminals. Okay, the letters which are denoted in capital letters, then we can say that is the non-terminal. Okay, the next one, type 1 grammar. It is called context sensitive language. Okay, this is called context sensitive language. This grammar contains the restriction that the production. Here also the form is alpha tends to beta. The length of beta is larger than or equal to the length of alpha. Okay, left side is here left side is denoted by alpha and right side is denoted by beta. The length of beta is, beta means right side element. Okay, length of beta is larger than or equal to the length of alpha. Here the length is what? 4 elements here. Here 2. The condition is true, right? So where the alpha is a non-terminal and beta is a terminal. Okay. And another one condition, the first condition is length. The length of beta is greater than or equal to the length of alpha. Okay. Students, please mute yourself. Number 37. Mute. Anyone please inform 37 to mute. Okay, fine. And the next condition is the beta should contain a terminal followed by any number of terminals. Okay. Okay, here we have the particular grammar should have terminal. This is not a context sensitive language. That is a type 1 grammar because it starts with a non-terminal. Okay, we have to start with a terminal followed by any number of terminals and non-terminals. No issues. Okay, the first condition is the length of the beta is should greater or equal to the length of alpha. And next one is it start with a terminal and followed by any number of terminals and non-terminals. Okay, this is the type 1 grammar. And next one is the type 2 grammar. Okay, This is the context-free language. This is only we are going to see in the third unit. This can recognize by push-down automata. Okay, the production must be in the form of alpha tends to beta, where the left side of production should contain only one non-terminal. In this case, there is no restriction on left side. Here they mentioned that left side we should have what? Only one non-terminal. Okay, in left side we should have only one non-terminal. Non-terminal means capital letters. Okay, but no restriction on the right side of the production. This language generated by this grammar or be recognized by non-deterministic push-down automata. Is it clear? The type 2 grammar is in the form of alpha tends to beta. We can say it is a context-free language. It can be recognized by the non-deterministic push-down automata. In left side, we should have only the non-terminal and only one. Okay. And in the right side, there is no restriction. Okay. This is the type 2 grammar. And next one is the type 3. We can say this is the regular language. Okay. Must have a single non-terminal on the left side. The same thing, previous one. Single non-terminal on the left side, and the right side consists of single terminal or single terminal followed by a single non-terminal. Okay. Type 3 grammar is nothing but regular language. It generates the regular language. We can say this is a regular grammar. Okay. Here the condition is in left side we have only one non-terminal. It is like previous one, type 2 grammar. And in the right side, in previous one, type 2, there is no restriction. But here, we can have what a single terminal or single terminal followed by a single non-terminal. Okay. Terminal means smaller case, right? This is the terminal. We can have this one. Otherwise, single terminal followed by a single non-terminal. This one, single terminal followed by a single non-terminal. This is allowed, and this is also allowed. This is nothing but we can say this is also terminal. Okay, epsilon empty. There is no input. Okay, we can say this is also terminal. Okay, in this example, these three things are terminals, and these three are non-terminal. Okay, these are the productions. This is called type 3 grammar. Okay, can you able to differentiate 4 types of grammar? Type 0 means all grammars are in the form of alpha tends to beta. Okay, there is no restriction in type 0 grammar. And in type 1, the beta length of beta is should greater than or equal to the length of alpha, and we have terminal followed by any number of terminals and non-terminals. Okay, so type 1. And in type 2, this is the context-free language accepted by push-down automata. And here the condition is left side we have only one non-terminal. Okay, right side there is no restriction. And type 3, in left side we have only one non-terminals, and right side we have terminal itself or terminal followed by one non-terminal. Okay, this is the type 3 grammar. Next one is the definition of context-free grammar. Okay, now you know, right? 4 types of grammar and its rules. If they given some production, can you able to identify the particular production is belongs to which grammar, right? Are you following, all of you? Are you following? Anyone can respond? Are you following?
Yes, ma'am.
Yes. Thank you, Nityashree. From boys side, anyone?
Yes, ma'am.
Yes, Jacob. Very good. Okay. Now we are going to see the definition of context-free grammar. It consists of finite set of grammar rules. Is a quadruple where 4 tuples are there here. N is set of non-terminal and T is set of terminals. And for example, if we have the non-terminal is capital A and we have terminal small a, then there is no connection between both of them. Okay, this is separate non-terminal, this is separate terminal. There is no connection between them. Okay, and P is a set of rules productions. It is the combination of terminals and non-terminals. And S is the start symbol. Okay, you start from the start symbol. Yes, we can have any letter in this start symbol, but commonly we can say S is the start symbol. Okay, this is the context-free grammar. The context-free grammar consisting of 4 tuples, which are they? Non-terminals, terminals, production, and start symbol. Okay, is it clear? So here I have some examples. The grammar, I'm going to create on grammar with this one. First one is the non-terminal. The grammar consisting of non-terminal is capital A, and this is the terminal. The second term is terminal A, B, C, and third one is the production. And the start symbol here is capital A. Okay. Generally, we can say the start symbol is S, but we can have any capital letters. Okay. This is the production. A tends to AA and A tends to ABC. Okay. This is the context-free grammar. Another one example. Here terminals and non-terminals. This is the terminal. So production, this is the start symbol. Okay. This is the terminals, production, start symbol. This is the non-terminal. We can have any number of terminal. We can have any number of non-terminal. Okay. This is the some sample production. S tends to A, S, B, and S tends to epsilon. This is also terminal. Already I have explained. This is also terminal. Okay, these are the some sample example for context-free grammar. Okay, CFG. This CFG only we can accept by finite automata. Okay, the same thing. The CFG have the following components. What are they? The terminals, non-terminals, production, start symbol. Okay, a set of terminal symbols which are characters that appear in the language or string generated by the grammar. The terminal symbols never appear on the left-hand side of the production rule and are always on the right-hand side. Yes, right? Terminals is nothing but small case letters. We can have this terminals in the right side only, not in the left side. So next one, the set of non-terminal symbols or variables which are placeholders for patterns of terminal symbols that can be generated by the non-terminal symbol. These are the symbol that will always appear in the left-hand side. We know, right? Non-terminal means what is that? It is a capital letter. Okay, and it can be placed in the not sure, we can have in the left side and the right side also, but left side we should have what? Non-terminal. It is deriving something, it denoting some kinds of terms with the help of terminals, combination of terminals and non-terminals. Okay, and set of production rules, which are the rules for replacing non-terminal symbols. Yes, production is nothing but S tends to some words, some sentence or some grammars, some productions. Okay, we can replace this S by this term. Okay, which one is having? For example, S tends to A means I can replace the particular S with A. Okay, this is the meaning. This is the purpose only we are using the productions. Is in having some form that is nothing but this arrow, right? And start symbol is nothing but which is a special non-terminal. Okay, start symbol also the one of the non-terminal, but it appears in the initial string of the particular production. These are the components of context-free grammar: terminals, non-terminals, production, and start symbol. If you're denoting the context-free grammar, you have to tell with these 4 tuples. Okay, these are the some sample productions. E tends to I and E tends to E plus E, anything it may be. Okay, Here, please tell me what are the, how many non-terminals are there? Which are they? Please, anyone? How many non-terminals are in this productions? And which are they? Non-terminals. Non-terminals means non-terminals. How many non-terminals are there here? Students? Which are the things you can say non-terminal in these productions? Yes, students? Yes, students, tell me what are the non-terminals appears here? In this production, what are the non-terminals? No one in the meet, right? Yes, number 174, Nirmal Verma. Can you please tell me what are the non-terminals in this example? Yes, unmute and speak. 174, Nirmal Verma. Are you in the meet? Try to interact. This is not a theory subject. Please interact. If you interacted and interested towards this subject, then no need to study after the class. You can learn here itself. If you followed all the instructions, if you know the concept, then you no need to study for the exam. You just go through the concept and you can write. Is it so? If not answer, not interacted means you can't able to study this subject and write. In online, all peoples are write well. I can see the, I can't able to differentiate those who are studied well or those who are prepared well and did by own or copied. I can't able to differentiate. All are writing in the same way. There is no mistake in your paper. The mistake is happen only in the copying. If one followed a diagram in one manner, means the same manner all the peoples are drawn. I don't know how it's happened. If you're writing in your way, own way, 8 states are there. Okay. Particular diagram having 8 states. We can mention the states in anywhere. 1, 2, 3, 4, 1, 2, 3, 4 like that, or 1, 2, 3, 4, 1, 2, 1, 2, 1, 2 like that. Any way we can represent. We can represent the states and we can make the transition value. But you all people done in the same manner. One started with like that, the state particular diagram having 8 state. You started with one people, one student may start with like this 4 states and here 4 states. Okay, the same manner all followed. Here transition goes here. From that only I can know, right? How we can go with all in the same manner? That is not possible. You can draw this diagram like 1, 2, 3, 4, 5, 6 like that you can go. Otherwise here also you can go, but all people are drawn the particular diagram in this manner. With copying no use. Try to understand and try to interact, try to prepare well and do. In the case of TOC, no need to prepare more. If you listen the class carefully, then no need to study. You can just go through the concept before the exam and you can write. If you find the trick, then it will be easy for you. For each and every subject, have some trick. Okay, please now tell me what are the non-terminals here.
Ma'am,
Yes,
ma'am, is it A to Z?
A to Z. Whether it is a terminal or non-terminal, you're saying
Non-terminal, ma'am.
I'm in previous slide I mentioned no what is my non-terminal, how we can mention the non-terminal.
I thought that would be by capital letters.
Yes, capital letter. Which are the letters in the capital, that is the non-terminal.
Yeah,
Which are
ma'am, but
yes, which are the things here mentioned in capital letters?
A, B, L, A, B to Z, L, and L is also included.
Sure, this is in capital letters. Yes, anyhow, Pragnesha only responded. What about others? The letters which are represented in capital form, then we can say that is the non-terminal. Now, please tell me. Yes, Leela Nityashri, what about you, ma?
EIDL.
Yes, very good. E, I, and D, L. These are the things we can say non-terminal. Okay. The letters which are represented in capital form, we can say that is the non-terminal. It derives something. It may leads to some form or some rules or some grammars. Okay. So the letters which are mentioned in capital form, we can say that is the non-terminals. E, I, and D, L. These four things we can say non-terminal. Then what are the things in terminals? Terminals. Terminals. Any terminal is here? Students, please respond me. Don't waste my time. Here, any terminals is there? Number 2, Abhimanya, are you in the meet? Definitely, I will mark and reduce some marks. Okay. If not responding. The letters which are in the smaller case, we can say terminals. Okay. Here, any terminals is there? Here, A to C. Okay. This is the terminals. And other than non-terminal, everything under the terminals. Okay. Non-terminal is nothing but which is in the form of capital letter, right? Other than non-terminal, remaining things are the small case letters and operators. Okay. And all other things come under the terminals. Here we can say the plus is a terminal, and this one also terminal, and this parenthesis also terminal, and 0 to 9 also terminal. Is it clear, everyone? What's the terminal and non-terminal? Is Pragnesha? Can you able to follow?
Yeah, ma'am. Ma'am, but I have a doubt.
Yes.
Last, they have given A to Z now. What is it, ma'am? L tends to.
Yes, in the case of L, we can substitute anything it may be. A to B, A to Z, or A to Z.
Will it not come under non-terminal?
Yes,
ma'am?
yes, ma, yes, ma. I missed that. This is also
Yeah.
come under the non-terminal. Okay.
So by saying that, I said A to Z, mom.
Okay, fine. Thank you.
Yeah, mom.
Mm.
Yeah.
Okay. This is the terminal and non-terminal. Now we are moving to the derivation, how we can derive from the particular grammar or particular productions. Okay. Here we have two methods, bottom up and top down. We know, right, what's the bottom up and top down. We are deriving from top to bottom, then we can say top down, or otherwise bottom up. Okay. In the case of we can say bottom up. In the case of here, bottom up is, we can say, recursive inference. Okay. This is not much important. We'll see what is the mean by that. But the most important one is the top down. Here we have two types of derivation, leftmost and rightmost derivation. We are just going to derive the particular string from the grammar. Okay. We are just substituting the value for the particular grammar and try to get the string. Okay. Process of coming up with strings that satisfy individual productions and then concatenating them together according to more general rules is called recursive inference. Just we are here start with a string and try to get the productions. Okay, here we start with a production and try to get the string. Okay, this is the difference. In top down we have two most derivation, leftmost and rightmost. Leftmost derivation is nothing but, for example, if I'm having that production as A tends to AB, S tends to AB, okay, and for that A, I have another one production as A tends to small a, okay, and another one production for B is B tends to small b, okay. Here the non-terminals are SAB and terminals are AB, right? If we are going to substitute, we are going to derive some string. How we can derive the string? Finally, if come up with the terminals, we can achieve. Okay, we are substituting some values for the non-terminals. Finally, we need to reach the terminals. Okay, this is the concept. Start with the non-terminals and try to reach the terminals. Okay, so here if I'm substituting A first, I mean, A means we can substitute A by small a, right? In this case, in this way, I can substitute. Okay. And after that, if substituting B means, this is called leftmost derivation. First, I substituting the leftmost element. Okay. Then substituting the element B. If I'm substituting that rightmost element first, mean that is called rightmost derivation. Okay. This is the difference between leftmost and rightmost derivation. For that in left side we have some non-terminals, means we can substitute for that non-terminal. If we start with the leftmost element, then we can say leftmost derivation. If we start with the rightmost element, then we can say rightmost derivation. We can mention like this derivation in the form of we have to mention like this. Okay, a leftmost derivation is simply one in which we replace the leftmost variable in the production body, one of its production bodies first, then work away from left to right. We can successfully denote leftmost derivation is like this. LM. Leftmost derivation we can mention like LM, and rightmost means RM. Okay. We will see with the example, then it will be clear for you. This is the rightmost derivation. For example, here I'm having that production is S tends to A, S, B, and S tends to epsilon. Okay, this is all. Is here, tell me what are the non-terminals? What are the non-terminals here and what are the terminals? Can you able to find?
S is non-terminal.
Mm.
A, B, and epsilon is terminal.
It's very good. Thank you, Nitish. What about others? Can you able to find out, ma, what's the terminal and non-terminals? Here I'm going to derive the string A, B, B. Okay. How can I get any idea? I'm going to use these two productions only, but I need this string. Is how we can do? How we can do? I'm start with the start symbol. If you're going to derive any string, means you have to start with the start symbol. Okay. A, S, B. This is the first production I have started. I need the string of A, B, B. How can I get? Any idea? Anyone? In this example, now I just started with a start symbol, start production. Okay, fine. Now I'm going to do what? I'm going to substitute the value for right side variables. Okay, right side means this one. This is terminal, already terminal, no need to substitute anyone. This is also terminal, no need to substitute. This is the non-terminal. I can substitute anything here. Which one I can substitute to get the string AABB? You have to think. Okay. Here only one production, no issues. If so many productions are there, means you have to think which production will give this string. Okay. Based on this, you can substitute the productions. Now please tell me, AB is the terminal, no need to substitute anything. The S is the non-terminal. In this place, we can substitute. For S, we have two productions, right? One is ASB and another one is epsilon. In these two, we can substitute anyone. Which one I can substitute to get the string AABB? Please, anyone?
ASB, ma'am.
Yes. If you substituting this epsilon, the string may be AB only, right? Epsilon is empty, so I can have the strings AB, but I need to have the string is AABB. So I can substitute the particular A with, particular S with what? Again, A, S, B. Again, another one B is there. Okay, now I have substituted S with these three elements A, S, B. Again, tell me again, another one non-terminal is there. Which one I can substitute here to get that particular string?
Epsilon.
Is epsilon. So my string is AABB. I achieved the particular string, right? This is the way we can derive. Okay, this is the derivation. We're just deriving something, deriving the string from the production. Okay, in that only we are having two types, leftmost and rightmost. Here only one non-terminal is there. If we are having two non-terminal, we can substitute from left side or we can from right side also. If you're substituting from left side, we can say leftmost derivation, and we are substituting from right side, then we can say this is the rightmost derivation. Okay. This is the recursive inference. This is nothing but bottom-up approach. Okay, bottom-up approach. We are taking the string. Based on the string, we just find the production on that, and finally we get the value. Okay, combine all the production, and we can say the string is accepted or not. First, we see with the leftmost and rightmost, then we come up with the recursive inference. Okay, then it will be easy for you. Yes, here. This is the productions, ma. For the production E, we have how many terms? 1, 2, 3, 4. 4 terms we have for the production E. We can substitute any one. Okay. For the purposes, we need to succeed. We need to get the string W equal to A star A plus B 0, 0, 0. This string we need. For that, we can substitute anything from this row. And the production I having that grammars 1, 2, 3, 4, 5, 6. 6 production for I and 4 production for E. We can substitute anything. The main purpose is what? We need to have the particular string. Okay. First, we need to start with which one? First, we need to start with which one? Students, I'm going to derive the string. Okay. For that, I need to take the first production, right? This is the start symbol. Here, the start symbol is nothing but E. I have to start with the E. Anything, if you want to derive, means you have to start with the start symbol. Okay. E tends to I. Now, we can substitute anything, any production for this I. No need to give I. The start symbol is compulsory. The start symbol, you need to give start with the E. But the left side, you can give any production of E based on your string. Okay, which one you want. Based on this, you can, if I'm giving the I means, I can substitute A, B, right? I, A, I, B, I0, I1. This is the one. This is the thing only. But I can't able to star or plus. But my string is having the elements of star plus also. So I can't go with the I. Is it right? I start with the start symbol E. I can give any production of E first. Okay. But we need to start with the start symbol only. Compare with the string. You please find any one of the production from this. Okay. Anyone please? Shall I take E plus E or E star E? If we're taking this string, this manner means we can divide this into two, like, so we can take E star E. Okay, I just taking the production E star E. If you taken E plus also, it may be helpful to derive the particular string. Okay, now I'm taking the string as E star E. Any doubt, please ask me. Students, have any doubt, ask me, otherwise follow. Okay, E star E. Is it clear what I'm doing? I'm going to derive the string. For that, I can use this production. I should start with a start symbol. E is the start symbol. I just started. For that, I need to give production. Based on the string, I can give the production. For the variable, for the non-terminal E, I have how many production? 4 production. In that, I can give anyone. Okay. Based on the string, I given that E star E. Okay. Now I'm going to substitute values for this one. I am just go with the leftmost derivation. So I just taken the leftmost variable. I'm going to substitute based on the string. I need first what? The variable A. Okay. How can I get? If I'm substituting for this E, I'm substituting I means, then for that I can give A, right? So I can substitute here I. Okay, the next step, the second step, I star E. Okay, I star E. And the third step, I can give the, for the particular I, the production, I can give the value A, because I'm having here I tends to A. So I can substitute A for the particular I. Okay, A star E. Okay, now my production is having E tends to A star E. And after that, I need to give what? I need to do what? Now this portion is I have achieved. For this portion, I need the parenthesis and plus symbol also. Based on this, I can give the production. Okay. For this variable E, I have to substitute something. How can I substitute? Based on this, based on the string, I can use parenthesis. Which production having with the parenthesis? This one. So I can substitute for this E, I can substitute what? This one. Is it clear? All of you, are you following? Okay. Now my string is having, now my term is having A star E. Okay, now the E substituted. After that, then I need to have what? A plus some term, right? So the plus symbols need to hum. So I can substitute this production. Okay. So E plus, for this E, I can substitute, open parenthesis. For this E, I can substitute E plus E. E plus E. Okay. Okay, fine. Now I have achieved that A and stitch and open parenthesis, close parenthesis and plus symbol, everything. Now I need to what? A, this particular term. So I can substitute A directly to that. Is it possible? How can I get terminal A here?
I substituting.
Yes, I can substitute I here. Yes, Dinesh, thank you. So I can substitute I here. Okay. Then I plus E. After that, for this I can substitute A because I have the production items to A. So I can substitute A here. Okay, now my term having A star, open parenthesis A plus E. Okay, now I need to want this term only. Other things I have achieved. So I need to have B000. Okay, how can I do that? Any idea? Please think.
Ma'am,
Hmm.
instead of substituting E for E, we can substitute I0. No,
What more?
ma'am.
Yeah.
Instead of substituting E there, we can substitute I0. No, ma'am.
Yes, for that we can substitute I0. Okay, I0 we have the production. Then after that, what is the next process? Now I substituted I0.
Again I0.
Okay, for this again I can substitute I0. So my term is having A plus I00. Then
One more time I0 and B. Ma'am.
yes, after that also I can substitute I0 for that particular I. So my term is I 0 0 0. Okay, now I need to want what for this I have to do what, which one? The variable B I want. Okay, so directly for that I have production B, right? This one, the second production. So I can substitute B here, B00. Okay, this is the way we can derive the string. Is it clear, everyone? Any doubt? Any
No,
doubt, ma?
ma'am.
Okay,
No doubts, ma'am.
okay, fine. So this is the way we can derive. This is called left derivation. Okay, I just substituted for the leftmost element only, right? If you go with the, if you come up with the right side element, then we can say that is the rightmost derivation. Okay, is it possible? You please try and tell me. Now having the value E star E. Okay, in that I'm substituting the leftmost element first and then go with the right side. Here also having two variables, but I substituted the leftmost element, then right. If you're substituting with the rightmost element, what will be the process? You please check and tell me. This is that is the rightmost derivation. Okay, this is the leftmost derivation which we have done already. You have to mention with this arrow, and leftmost derivation you can mention with LM or LMD. Okay, all of you clear, right? Please come up with the rightmost derivation. Is it possible? Check and tell me. Can you able to do with the rightmost derivation? Anyone? Have you done?
Yes, ma'am.
Okay. Others, please. Some other answer I am expecting. Can you able to derive the string with the rightmost derivation?
Yes, ma'am.
Yes, yes, then. Boys, anyone done, pa? Boys, please, anyone respond? Can you able to follow the rightmost derivation?
Yes, ma'am.
Okay. So this is the leftmost derivation. For rightmost derivation, we can please check with this. Those who are done, please check with this how you got this answer. This is the leftmost derivation and rightmost derivation. Okay. In exam they may ask give production sensing and give the production give the derivation of leftmost or rightmost, they will ask. Okay. Okay, fine. Now I come up with recursive inference here. That is the derivation top down, right? Here this is the bottom up. Here the same question, same production and same string. How to do what? They will ask, can you please give the derivation or recursive inference? If they are asking the recursive inference, you have to go with this way. Okay. First you start with the string A. Where I can get A is definitely from I. Okay, so I can say this is the language L. Just I'm mentioning the production's name 1, 2, 3, 4. Here for the E, we have 4 productions, so I can go with this 5, 6, 7, 8, 9, 10. So totally we have 10 productions. Okay, so that's the thing here mentioned. Like for the each and every term, you have to get for the variable A and the star plus everything you have to get. Next one is the here taken the how they are taking means start with the inner loop. Okay, here the string is A star A plus B 0, 0, 0. Okay, just try to get the A and B and this term. Okay, then plus A plus this term, the total term, and A star. Okay, like that we can go. So first start with the A, where I can get the production I. This the name of the production is 5, no issues. This is not a compulsory one, you can mention with the I. And the next one, the variable the terminal B, so where I can get the variable B. This is as per your wish only, you can draw. Finally I need to have what, the particular string. Okay, the next one's B, I can get the terminal B from the production I. This is the production name is 6 and B0. How can I get B0? How can I get? Where I can get B0? Students, the reverse process where I can get B0 here only, right? I0, for that I can substitute the B again. Okay, so it is also from the ith production. Okay, is it clear? The production number is mentioned here and B00, the same I. Okay, the production name is 9, and now my value is having B00. Another one 0 is no. Yes, again another one 0 is needed here, missed. So next one is the B000, that is also I and also the 9th production. And next terminal is A. A is come from where? Where I can take the A? I can take the A from I, right? But here mentioned with E. Why? Any you can able to follow what's the things happening here? I can replace the A by I, right? The production I having the production of A, I tends to A, but here replaced with E. Why?
Ma'am, in one we have replaced A with I and replace I with
Yes,
E.
yes. For the purpose of nothing but for the purpose of the whole term. Okay, not for a single term. For the purpose of whole term, we are just mentioning with E, then we are giving the value. Okay. So here B00, again another 1 0 is also needed. Here missed that one. A plus B00 means again we are combined with the production, this one E plus E. Okay, just combine this one. Okay, the production fifth one, here one, this one A, and sixth one, we combine both the things. with the help of the production E. E tends to E plus E. Okay. And again another one, this is for parenthesis. We have the parenthesis here, fourth production. So I can get the fourth production. From this one, we get this one. Okay. So just substituting the production E. Finally, we have the multiplication A star. So I can have with which one? 1, 2, 3. Third production. Okay. Here. With the help of fifth one and eighth one. Combine both the things and get the string. Okay, this is the recursive inference. Not much important. Anyhow, you have to know. Maybe ask. Okay, recursive inference is nothing but bottom-up approach. We take each and every terminal or every term in the string. For that string, you have to find the production, and finally, you need to have what? Finally, another one thing is here important is finally you need to have the particular string with the start symbol. Okay, we have to conclude with the start symbol only. In the case of top down, we just started with the start symbol and derive, right? Like that, here also we have to conclude with that start symbol. Okay, this is the main concept. Other than we just copy the production into the respective term. Okay. Time over, Noma. Please note some homework. A star A plus B1. Please make a note of these productions. Please make a note of this production, ma. A star A plus B1. You please derive with the leftmost and rightmost. We will see in the next class. Okay. Please all of you note this production. E tends to I. E tends to E plus E. E tends to E star E. E tends to open parenthesis E close parenthesis. I tends to L. I tends to ID, I tends to IL, and D tends to 0 to 9, L tends to A to Z and A to Z. Okay. You have to derive the string A star A plus B1, right? A star A plus B1. Have you noted, all of you? Students, respond me. Have you all noted?
Yes, ma'am.
Okay. You have to derive the string A star A plus B1 with leftmost and rightmost. Okay. Thank you, students. You can go for a break. We will see in the next class. Okay. Thank you.